Welcome back. In this video, you will learn a module called NumPy. What is a NumPy module? A NumPy module is a package in Python that stands for numerical Python. It is a core Python module for scientific computing. It is also powerful to create an n-dimensional array object. This NumPy package is useful for linear algebra in Python. And in fact, most of the Python packages always rely on this. So how do we install NumPy package? In the previous module, which is CS21, you've seen how we install Anaconda distribution. So which means that if you have installed Anaconda distribution, you don't need to install this NumPy module because Anaconda distribution has this NumPy module installed. So how do we import a NumPy module? To import a NumPy module, you will use this syntax called import NumPy as np. As you can see, import NumPy as np. This NumPy is the module that we want to import, and then we have the alias called np, which means that anytime we want to use NumPy module, we will use this np to reference it. Let's go to the lab session where we will see how to use NumPy in action. Throughout this lab session, we'll be using this folder called snippet codes for CS22. I will advise you go to the LMS and download this material. After you have downloaded it, you may want to put it in your desktop. And from there, we are going to open JupyterLab Notebook to access this file. So I go to my search bar and I type Anaconda prompts. So after this Anaconda prompt, as you can see, it's loading. Then you type JupyterLab to open or to launch JupyterLab Notebook. I have an error because I misspelled it. Then I type it again, JupyterLab. I'm going to wait for it to open a window. As you can see now, we now have JupyterLab Notebook launched for us. To follow along, you will have to open this file from the folder that we just downloaded. To see that folder, you will need to click on this file browser, then click on desktop. Alright, look for this snippet code for CS22 folder. You double click on it and then you will see this NumPy notebook. So if you open it now, you now have something like this. So let me close this guy because I already have it opened. To see this JupyterLab notebook clearly, I can hide this one here by clicking on it so that you can see everything at a glance. Now, let's see what NumPy module has to offer us. As we said before, you need to import NumPy module. And to import it, you have to say import NumPy as np. So let me press Ctrl Enter to run it. Now, as you can see, it has been loaded. Let us now see the difference between Python list and NumPy array. Remember in CS21, you know how to create a Python list. And to create a Python list, you have to use this square bracket. As you can see, square bracket, put your element there and end the square bracket. We said that Python list can accept different data types such as a string, an integer, a float, or a boolean. Now let me run it now. With the help of this function called type, I can see that the kind of object that is saved in this Python list is a list. And these are various data types that this Python list as in store. As you can see, Ethiopia is a string, 5 is an integer, 17.9 is a float, and true is a boolean. Now let's see what a NumPy array is. A NumPy array is like a list, but NumPy array has more things to offer us. For example, let's see how we can create a NumPy array. In this case, we will be creating a Python list first. And to create a Python list, remember, you will use a square bracket and you put all your elements there and end it with a square bracket. Now I have a Python list. To convert a Python list to NumPy array, we are going to use a function called np.array. Remember, np is the alias for the NumPy package, and out of that, we want to get a function called array. So therefore, we are going to say np.array. Since np.array is a function, then we can now put our Python list inside it, and then we run it. If you look at the type of object that this one is, Python is telling us that this is a NumPy array. Okay, so let's see what is in this array. To get what is in this array, you may want to call the name that you store the array with, which is the NumPy array from list. Now I run this guy, see what I have. It's telling me is an array, which is having 1, 4, 7, 12, 1, 4, 7, 2, 12, 17 as its elements. Another way at which you can create a NumPy array is by just using np.array, a function, and then put your list there instead of creating a variable for list. You could have well just create it with just one line of code, as you can see it here. So now if I run this guy now, as you can see, I now have my array, which is 1, 9, 8, 3, and 12. One good thing about NumPy array is that you can do some mathematical calculation with it. But in the previous Python list, there's no way you can create a mathematical operation with it. For example, let me just create a list. Let's call it L1 and let's put some value there. So let's say I have 1, I have 2, I have 3, 4, and 7 like that. Okay, so let me run it. Now I have run it. So let us now say we are adding 1 to it. Let's see what will happen. L1 plus 1. See what happens. I get an error because this is a list, and that is why no mathematical operation can work with a list. In this case, we need to change it to NumPy array. So let's see how we can use NumPy array and do our mathematical operations on it. So in this case, I will just be saying that let's call it K2 this time around. So K2 is equal to np.array. You can press tab to autocomplete it. Array, alright, then with a parenthesis, now put your list inside that parenthesis. So in this case, I want to say 1, 9, 1, 9, or let me just use the previous example. 1, 2, 3, 5, and 7. So I run it. See now, I have my K2 being defined. So now let me now add 1 to K2. Just say K2 plus 1. Run it. Now you can see I have my answer now. So which means that 1 is being added in every element on this array. And that is the main reason why people always use array when they want to do any scientific computing. In NumPy array, we can do so many mathematical operations. For example, I have created this array which I saved in a variable, and now I want to be adding various values into that array. So in this case, I'm adding 2 with every element in my array A. So if I run it now, see what I have? I have the result 2 is being added to every element. As you can see, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, and so on. In this case, I'm subtracting 3 from every element in A. You see, I now have the result. Also, I have this example where I'm multiplying 2 in every element of array A. So now you see, I have the result. Here, I'm dividing every element by 2. Now, I have the result, as you can see. So, in the last example here, I want to get the cube of every element in array A. That is why you can see this is an exponential operator, which means that we are raising every A to 3, every element in A raised to power 3. And if you run it now, I have the result. You can see that NumPy array is interesting, right? It's very simple. The first thing you must learn is learn how to create your array by using this function np.array. And inside that function, you put your list there, and that's all. So let's see another example. In this example, I'm creating two arrays. The first one is array A, and the second one is array B. So let me run it. I have my result now. You will note that I have the same elements in array A and array B, and from that I want to get a result of A plus B. So if you run it now, so what this will do is that it will add every element, because this will be like element wise. 5 plus 3 is 8, 2 plus 2 is 4, 7 plus 4 is 11, and so on. In another example here, I am subtracting B from A. So if I run it now by pressing Shift Enter, you can see I have my result. Here, I am multiplying those elements by each other. Now, you can see I have the result. So, array is very simple. The same thing with addition, or the same thing with division. As you can see, this is the divisor sign. Now, I have my result now. If I run it now, as you can see, I have my result here. So the other one here is where I'm using modulus. Remember, modulus is the remainder when you divide a number by another number. So if you divide A by B, the remainder for each element is what we have here. Very interesting. This one, I am squaring every element of B by A, and I get the result. We have now come to the end of this video. We will resume back to see how we can index NumPy array. In the last video, we have this NumPy array A, and as you can see, this is the array A, 5, 2, 7, 4, and 12. Let us see how we can get the square root of every element in this array. So here, we are going to use np.sqrt, and this will give us the square root of every element in this array. Now let's run it, and this is the result. As you can see, the square root of 5 is 2.23, and so on like that. Now let's see how we can index a NumPy array. In CS21, we look at how we can index Python list. Since you know that Python index starts with 0, the same thing applies to NumPy array. So let's see. I have this array, that is 1, 2, minus 1, and so on. So I run it, I print the result, and I have this. So let's see. You can see if we have this as our array, then the index, which is the first number here, will be 0. The index of 2 will be 1. The index of 10 will be 9. Since Python index starts with 0, we keep on counting it until the end of the array. Okay, so now let's use this index to get our element from the array. So to get the value of 1 in this array A, we are going to use its index. So in this case, I will just say A square bracket 0, and you see I have the result here. So if I run it again for this index 3, I'm going to get 4. Okay, and let me create a new cell. And let's say I have a, let's see the index of let's use 8 as index. As you can see, our value that we return will be 9 because 9 has index 8. So if I run this guy, see what I have 9. Okay, we can also replace the value of an array, okay, using its index with another number. So in this case, I'm going to replace the value that has index 2, which is -1, with 5. So if I run it, see what I have. Now if you look at the new array now, you will note that -1 has been replaced with 5 because that is exactly what I did here. Now you see how we can index value of an array by using its index. Sometimes we may want to get values that has more than one index, and let's see how we can do that using array slicing. Remember, array slicing or NumPy list slicing starts with this: the start number and the stop. And if we omit the start number, then that start number will be 0. And also, if we omit the stop, then the end will be the last index of that array. And also, if I have index 1 to 3, remember what I will now get is 1 and 2 because Python will be subtracting -1 from the stop here if it is written in full. So let's see it in example. I have this array that is 2, 4, 6, 5, 8, and 9. Let me run it. Remember, it is not necessary if you don't put print here, you will still get your result. Okay, if you don't put print, you have array, but if you put print, it will only print it in a good form. It removes the array, although it's still an array. Because if you look at the type here, you see type A, you still get an array, as you can see. Okay, great. So let's also define a variable B which slices elements from array A. Now in this case, see what we are doing here? We are saying from 0 to 2. So inwardly, Python will be doing something like this: 0 and 1. Because if you make it in full like this, Python will subtract 1 from the last number here, which is 2. And that is why we have 1 here. So then we have 0 to 1. Now let's run it. As you can see, we have 2 and 4 because 2 has index 0 and 1 has and 4 has index 1, and that is why we have this. Let's see another example. So in this example, I'm defining an array called x, and in that I have this, that is 5, 8, 9, 2, 4, 6, and 5. So let me run it. So here I want to print, I want to slice values or index from 1 to 3. Remember, in this case, I will be having something like 1, 2. Since 3 will not be there because 3 is the last number, so Python will subtract 1 from 3. And here, I will now have 2. So let me remove my comma. So in this case, I will be looking for the index 1 and 2. Then I will now get their values. Look at it here. 8 has index 1 and 2, and 9 has index 2, and that is why we have both 8 and 9. That is why we now have 8 and 9 being returned for us. I hope you are mastering it now. So in summary, if you did not put any value at the starting point, Python will see it as 0, and in that case you now have 0, 1, and 2 because the stop value is 2. You see here, you did not have the endpoint. So what Python will do is to start with 1 and then make the endpoint to be the last index of your array. So let's see it in example. So in example 4, I have this. I have my array and I'm asking, starting from 1 to the end. You can see that the index 1 is 4 and Python will now see it from 4 to 5, and that is why we have this. Okay, so let's see this one also. Remember, all this is what you learn in CS21, where you are slicing NumPy, where you are slicing Python list. So I have my array X, and from there I'm getting, starting from 2 to the end, and here is 2, so I will have 6 to 9, and that is the reason why I have this. Okay, I believe you can do all this. Okay, so one other thing is that it depends on how you put it. So let's say I have this array A and array B. Okay, this array A is from 2, 1, 7, 4, 6, 8, and 3. And the array B is from 0 to 7. Remember, this will be from 0 to 6. And that will be 0, 1, 2, 3, 4, 5, 6. Okay, and that is what we have as B. And if I run everything like this, I will have each of these being printed here, which is giving us the same thing. Remember, this is our array A. We are getting B from A, that is from 0 to 6. That is what gives us our B, and the B is what got printed here. And also for C, we are getting it from A, but in this case, as you can see, the starting point has been omitted, and in that case, it will be 0. So we are now having from 0 to 6, as you can see. That is why we have all this. So you may want to play with it for you to understand it better. We have now come to the end of this video. In the next video, we will see different attributes of a NumPy array. There are many attributes for NumPy array, and they include shape. Shapes indicate the dimension of an array. We also have size, which returns the total number of elements in an array. Then, another attribute for a NumPy array is called dtypes, which return the type of element in that array. Let's see an example. In this example, I have a NumPy array called even array, where we have even number from 2 to 16. Okay, so if I say even array dot shape, then I will get its shape, which is 8. Let us run it. We have 8 here because this kind of array is like one-dimensional array. That is why you are seeing the number of elements here separated by a comma, because this is not a two-dimensional array. To get the size of an array, to see the number of elements in an array, we use this attribute called .size. So let's run it. .size. Remember, you may not want to put print and it will still work. For example, the name of the array, even array dot shape, to see the shape of that array. This attribute has no parentheses. It's just like this, shape, and you get your result as 8. The same thing with size. The size will give you the number of elements in that array. So in this case, I'm having this even array, then dot size, which is the attribute I'm interested. So I have 8. And to get the kind of data type that is in this array, I may want to use even array dot dtype, which will give me the kind of data type that it is. So let me do it here without print. Even array, that's the name of the array, dot dtype. Dtype and you run it and you get result. Now you can see this is an integer array. Let's see example 2. In this example 2, we have this array called sum array. So let's run it. Now we have it. So to get the shape of this array, remember this is a one-dimensional array. You can just say sum array, the name of the array, followed by the attribute called dot shape. So I have this, and you can see 25 comma, which means that it's a one-dimensional array. And to get its size, you just include dot size to the name of the array. Then you can see we have 25 elements in this array. Let's see another way at which you can create a NumPy array. In this case, we will use what is called arange. Arange function is similar to the range function that we have seen in CS21. So let's see. Let's say you want to get an array from 0 to 5. You may want to say np.range and put 5 inside the parentheses. As you can see, we have the result as 0 to 4. So this arange will subtract 1 from here and you get the result as this. We also have another one, np.arange 10. When you put 10 here, then it will start from 0 and end result as 9. Now we have this. Since arange works like range in Python, okay, it actually has its own argument like this: the first, the starting point, the end point, and the increment. So here the starting point is 1, the end point is 10, and the increment is 2. Now let's see. So we have 1 here, and for every element it will add 2 to it. You can see 1, 3, 5, 7, and 9. Since our array is not up to 10, because if you add 9 to 2, you get 11, and we are saying that we are stopping at 10. That is why we have this guy here. So let's see another example for arange. Remember, you have to say np.arange. Okay, here I want to have number from 5 to 100. Then the increment is 25. Run it, and now you get the result. Okay, you can see 5 plus 25 30 plus 25 55 plus 25 80. So if you add 80 to 25, you will get something like 105. And since 105 is not up to what we are looking for, that is why it has to end it at 80. Another way at which you can create an array is by using what is called linspace. What linspace does is that it will evenly space number over a specified interval. So in this case, I want to generate number here, so I'm saying, okay, give me a number from 0 to 10. As you can see, 0 to 10, and just do it in this way. So the total number that we are looking for is 3, but spread the number from 0 to 10, and that is why we have this. Let's see another example. So here, as you can see, linspace 0 to 50, give me 10 number from 0 to 50. So if you run it now, we now have the result. And if you count it, you may want to count what is the result. For example, let's say copy this guy, copy it, Ctrl C, open a new cell, type len, close it, and do like this, and you get the result. You can see 10, because this is the space at which you want to distribute our data. We are saying that distribute it from 0 to 5, just give me 10 numbers out of 0 to 50. So this should be useful when you are creating data sets. A simple form of multidimensional array is what is known as two-dimensional array, which is the same as a matrix. And to create a simple two-dimensional array in Python, you are going to use list of lists. For example, this is a simple two-dimensional array, as you can see it here. So you will view this one as the first array, this one as the second array, this one as the third array, and you put all of them in each list. So let's see how we can create this two-dimensional array. So to do that, what we do is to first of all use is equal to np.array to create your array function. Array, as you can see, you close the parentheses and you put a list there. As you can see, first of all, you put square bracket, end it with another square bracket. Then inside that square bracket, you now start creating list for each of these row. So I will start with this. I will open this one here, as you can see, then type a list, that is 1, 2, 3, as it is displayed here. When you are done with this row, you may want to close the square bracket, which is this guy here, and separate it with a comma. Then you begin another list. So here you will put 4, 5, and 6. When you are done with that list, then you leave the square bracket, separate it with a comma, and then create another list. In this case, I will put 7, 8, and 9 in this list. 7, 8, and 9. And when I'm done with all the elements here, then I run it. As you can see, now I have my A. So to see what is inside this A, I can just call it A and I run it. Now I have my array. You may want to know whether this is an array by using type. As you can see, type A, run it, you get the result. Now it's telling you this is a NumPy n-dimensional array. Remember, in the previous video, we considered 3 attributes of array. The first one is shape, followed by size, followed by dtype. So let's see the shape of this array. So to get the shape of this array, you may want to use a.shape. For example, I can remove my print, although if you use print, it will still work. So to get the shape of this array, you can just say a.shape. Run it, it gives you 3 by 3. So 3 by 3 here means that you have 3 rows, and these are the rows: 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last 3 here is telling you that you have 3 columns. And the columns are 1, 4, 7, which is the first column, 2, 5, 8, which is the second column, and 3, 6, 9, which is the third column. We can also use size to get the number of elements in this array by using a.size. As you can see, a.size will give you the number of elements. And if you count it, 1, 2, 3, you see that all the elements in this array are just 9, and that is why this returns 9. The last attribute for this array is what is known as dtype, and you can check it by using dtype. Run it, it will tell you that all the elements in that array has integer, or they are integers. Let's see how we can create this other example. Here we have an array called another array, which has all this. So we may want to create it. Remember, to create it, you have to say np.array, and then you put this square bracket to specify that you are putting a list of lists inside it. And after that, each of these elements, 5, 6, 7, which is in the first row, you will put it in a list, which is this one. When you are done with the first list, you separate it with a comma and you start with another list, which is 4, 2, 1. After that, you specify another list, which is this one, 3, 7, 1, and then you run it. Now you can see that we have created this another array. And to get the shape, you can just say dot shape, and you get it is 3 by 3. To get the number of size, you may want to run it now. As you can see, now you have 9. You may be asking, why are we having 3 by 3? Of course, you can create another array which is not a 3 by 3 dimension. For example, let's say I have B to B, this one here, I say np.array. Alright, then I can put list of lists there, just two lists. That's how I want my list to be. So here I can just do like, okay, let me close this one, and inside it let me put another list here. So here now, let's say I have 4, 6, 8. Then I'm done. Then I create another list. Then here I'm having 2, 3, 1. This is what I want. Now let me run it now. Okay, it works. So we want to create a cell to see what that array B looks like. Now you can see we now have this array B. And to get the shape of this array, you can just say b.shape, b.shape. Now you have it. This is a 2 by 3 array. Now let's see how we can index an array, which is a 2-dimensional array. So remember that Python index starts with 0. And since 2-dimensional array has both row and column, then when we are indexing it, we have to specify the row position that we are looking for and the column position that we are looking for. Here is an example. So this one here, as you can see, this is the first column labeled as C0. C means column. 1 here represent the first column. 2 here represent the second column. So we are having 0 here because the index of Python starts with 0. Okay, so here now we have 1, 2, 3, which is the first row. Okay, and that first row will be noted as 0. So this one here, which is the second row, the index here will be 1, as you can see. And this one here, which is the third row, we have R2 to define the position. Okay, great. So let's create a matrix that looks like this. Now I have it now. As you can see, I've created it. Now let me now get this index 2. As you can see, 2 is here. So the first thing to do is to have, because an array is a 2-dimensional array. So we have to specify the row position followed by the column position. The row position will be here and the column position will be here. Now if you look at 2 here, you see that this 2 here is in row 0, as you can see, row 0, row 0. While 2 here is in the column 1, as you can see, this is column 0, this is column 1. So therefore, I will say 0, 1, 0, 1. So let's see, 0, 1. When you run it, you get 2 because 2 is in row 0 and column 1. So let's see how we can get 6 here. So to get 6, let me create a new cell. To get 6, I will first of all use the name of my array, which is A, followed by a square bracket, and then I will put the index there. So if I want to get 6 here, this 6 will be in row 1, as you can see, row 1 and then column 2. I just say 1 column 2 and I will get 6, as you can see it here. So let's see how we can get 4. The 4 is here, then we just say 1 column 0, 1, 0. As you can see, R1, 4 is in row 1 and 4 is also in column 0. So I will just specify 1, 0, and that is what I have here, 1, 0, and I get my 4. So let's see another example how we can get the value from a 2-dimensional array. So here I have this matrix. As you can see, I have this matrix. Sometimes I can call it matrix and I can also call it array. So I have this matrix 2, 3, 4, 6, 7, 8. So if I specify this, it means that in the row 1, this is row 0, 2, 3, 4 will be in row 0, and 6, 7, 8 will be in row 1. So since I need row 1, which is this guy here, and column 2, this is column 1, 2 and 6 will be in column 0, 3 and 7 will be in column 1, and 4 and 8 will be in column 2. So since I need 2, I will just do this one. And in that case, it will extract 8 for me. So let me run it. Now as you can see, you have 8. Other thing, for as you know that array is mutable, you can change the value of an element with another element. So here I'm changing this value of 8 to 20 by getting its by using its row and column position. Then the value of this 8 will now be taken for 20. So let me run it now. So if I do it now, as you can see, it has replaced 8 here with 20. So let's see another example. So let's say I have, remember this 3 here, I want to change it to 9. So what I will do here is I just say A, okay. So then let's specify the row position and the column position. Since I need this 3, the row position is 0, as you know. I just put 0 here, followed by the column position. The column position of this 3 is 1. Let's see, this is column 0 and column 1. So if I put 1 here, see what I have. It gives me 3. Now to replace this 3 with 9, I can just say it's equal to 9. When you run it, okay, it has replaced 3 by 9. But how can we see it? Just call the name of your array, which is my A. Then if I do like this, A, now run it, you get your result. As you can see, the 3 here has been replaced with 9. That is how to, number 1, index an array and to substitute its value with another value. Now, with the attribute, remember we have the attribute shape, attribute size, and attribute dtype. So this is exactly what we are doing here. And also we want to see how we can slice it. So if I run this, I have my array A, which is 2468 and 0541. I believe that you know how you can create this array. So let's see its shape. Its shape is 2 and 4, as you can see. Now let's see what this one is doing. So we are saying 0 2. Remember, we start with 0 and we end with 1. While this one we start with 0 and end with 2. So here we are saying we need 0 and 1 row. 0 and 1 row. This is row 0. This is row 1. Very good. And after that, here we need column 0 to column 2. Remember the last one, 3, you subtract 1 from it, so making 2. It now be from column 0 to column 2. This is column 0, this is column 1, and this is column 2. So in that case, I will be getting 246054, and that is exactly what I have here. As you can see, 246054. So let's see what this one is doing. Here I want to get array B from array A, and in this case here, as you can see, I have A with this square bracket. Since this is a two-dimensional array, then I want to specify saying that from 0 to 2, and this one here, because I did not specify anything, it means that it will extract all the columns for me. So let me run it now. You can see I have this one here. So what is the interpretation? Interpretation of this one is that it will start from row 0 to row 1. Remember, this is having the end as 2. So subtract 2 from 1, you get 1. So this will start from 0 to 1 while we are taking all the columns. So remember, this is it. Row 0 and row 1. So it will take everything, and then let's see its column. The column is that we are taking everything back, and that is why we have all this. And if you look at what we have in this array B, it's the same thing with what we have in array A. So which means that this one is showing us how we can slice our two-dimensional array. So this one as well is like, as you can see, we did not put anything here, only that we specify column. And when there is nothing except the column, it means that we are getting all the rows. And for this one here, it means that we are getting all the columns. And if I run it now I have everything. We have now come to the end of NumPy array. So in this video, we see how we can create a two-dimensional array, how we can slice its index, and we also saw various examples that can help us to know how to create a NumPy array in terms of two-dimensional array. We have now come to the end of this video. See you in the other section. Bye.